Hey, this is the coding teacher, and I'm back with a 5-minute LeetCode series. Today I'm covering this binary tree zigzag level order traversal problem. Again, a tree is just a node that has these characteristics, a value left and a right pointer, and then the left and right pointer points to other tree nodes. And in a binary tree, um, you basically just it's binary because it has two branches. If it were a binary search tree, there would be a restriction on the values, but this one doesn't have that. um, in an example right here, they're giving us this tree, and what we have to do is traverse from left to right in the beginning, then from right to left in the next row, then from left to right in the next row, and so on. So the output should be like 3, 20, 9, 15, 7, like that, as you see, right? So the second row is inverted. um, there is a solution to this that you can look up, that's pretty confusing, that involves using essentially two stacks. And I think that's not a great solution, and it's hard to get all the details right about it, and it's not very intuitive, and it's not easy to understand. So I'm gonna go with something much easier. So I'm gonna do a regular level order traversal and then reverse the odd levels. Um, so let's start with the implementation. And by the way, a level order traversal requires a queue. So you're basically adding every child that you see to the queue, and you continue the algorithm until the queue is empty. So let's go ahead and first just cover some base cases. If not root, or root dot if not root, then return 0. And then we're gonna say, and in here, it's not gonna be quite a level order traversal because we're gonna need two queues so that we can separate the rows. So we're gonna say current level equals root, next level equals blank, and result is this guy right here, right? So we're always gonna have the ability to append to result. We're always gonna have an empty. We should always have an empty array there whenever there's a new row that we need to start processing. Okay, so while current level dot length is greater than 0, and this is the part that's like reminiscent of breadth first search. So we just get the first elements. In that this would be kind of like the similar to a breadth first search stack, except that we're gonna be using it only one level at a time, and you're gonna see how that works. Um, result dot length -1 dot push current node dot value. Okay, so in this, I'm just pushing the current node into the last available array. Okay, at the end of the last available array. Then if current node dot left, then I'm gonna push next level dot push current node dot val, no, current node dot left, and I typoed that, and in here I go with right. And then now this is, so current level always starts out with something, right? And at any point in time, what I want to do is basically wind down the current level. So when I reach the end, because I you know removed an element from here, so if current node dot length is equal to 0, then I'm gonna go ahead and kind of like reset things, and I'm gonna say current level, not current node dot length, current level dot length, current level equals next level. Jeez. Next level. Oh my goodness. Equals that. And let's add another level to the result. So result dot push this. Okay. Now, so that should take care of forming the result, just forming the level order traversal in the result. So now we're gonna flip the odd numbered ones, and let's actually, before we do that, let's actually, because this, if you notice, right, when we reach the end of the last current level, we might be pushing an empty array that never gets anything added to it. So let's get rid of that. This is a little bit of like gross code, but it's simple to understand, so I'm keeping it this way because it's a relatively hard exercise. So if result, so this is basically the same thing right here. Dot length is 0. Result dot bob. We're gonna get rid of that last element. So, and now I'm gonna remember before I forget, because I just had that thought. And now we're gonna reverse right here. So for equals 1, I is less than result dot length, I plus equals 2. Then I'm gonna say result at I dot reverse, and that should take care of it. Let's see if we have any syntax errors. Yes, we do. Return. Interesting. That's an interesting perspective right there. Bold strategy, Cotton. Let's see how that pays off. All right. Okay. So that was accepted. Let's see. Let's just submit. And there we go. So that is a solution that I think is much more easy to remember and approachable for this problem. Now, if they ask you to, oh no, solve it in O of n memory or O of 1 memory, you're gonna fumble around with the. It's still the same basic thing, except you have to basically decide. You have to have another variable that's like left, whether you're going left or right, and based on whether you're going left or right, you do these in different order, and I think you also get this guy out in a different order from the beginning or from the end, whether you're going left or right. So I think it's much more complicated to remember and more error prone. So that's it for today's LeetCode grind. I hope that was informative, and if it was, please hit like and subscribe, and I'll see you guys next time.